Hello everyone, welcome back to TechFlow Media. Today we are diving into part 4 of our complete Siemens Electrical Designer tutorial series. In our last video, we successfully configured the infeed section and took a quick look at the different types of electrical load available in Electrical Designer. If you missed that video, make sure to check out the playlist linked in the description below. By the way, before we start part 4, I want to quickly cover a feature I missed in the last video. It is a language support. Okay, so if you click on the setting icon right here, right? If I click here, uh, if once it open up the setting, you can see that the software allows you configure your project in 7 different languages. If you drop down this filter, you can see these 7 languages. So that feature I missed, but you just refer it, and as per your requirement, you just configure your project in any of this language. And below this, one info button is also there. So here you can read some legal informations. Please go through it later. So I will come back to our electrical designer. Today we are going to focus entirely on the configuring a specific electrical load. As I mentioned, for today I have taken the motor load. Okay, uh, we will explore all the different filters available inside this section, and we'll see the purpose of each filter, so you know exactly how to use them for your project. Now a quick heads up, because a motor load has so many technical parameters to cover, today's video might be run a little longer than usual. I'm going to keep it as short, crisp and direct as possible, but I want to make sure we don't skip any details, so completely understand the purpose of each setting for your real world design. To save time, I have already taken care of the initial steps. Step 1, our project is created, and step 2, all the filters in our input section are completely configured. To understand it, refer the last videos. Now, if you see here, our current project is project motor load, and I configure the input section also. Now, let's see. We'll open directly the electrical load configurator. So just click on this electrical load icon from the SLD. Once you click on the motor load, you'll see the default headline. This is a motor, right? Below that there are two properties, two tabs. One is a property and another one is a load parameter. Below that, electrical load configuration headline. So this is the electrical load configuration window, and below of this configurator configuration headline, we can see one note. With the load configurator, you can configure an electrical load device that is used for selecting the control devices and for the cable dimensioning. So for the later phases, this configuration are very important. And if you see here, we have one warning message: further input required, the configuration is invalid, please select the valid configuration. So since we have to configure some mandatory parameters like the electrical mechanical power, then rated current, etc., that's why this warning will be there. But once we set it, this warning will be go away. So uh, at the so just I will collapse these parameters here what we have in the electrical load configuration. So we have the first one, input parameter. Second one is the basic configuration. We have the warning here. Starting and operating parameter also we have the warning, and advanced configuration. These 4 parameters we will see one by one. By the way, you can easily change this motor name from this property tab. If you go here and for example, if this motor is being used for the machine 1 or special conveyor belt, you can edit the text from the properties configurator. So for the demo purpose, I will just make sure that motor 1 I will type and click outside. So let's come back to our load parameter. So here I will expand the first expander, or we can say the group of parameter, that is input parameters. So uh, this, you can notice that these are all the read only properties, right? So we cannot edit any of this value from this load configuration. If you do need to modify your input parameters, you have to go back to the input configuration that we saw in the last video. So you have to go back to the in-pit configuration panel, which you can easily access either from the project tree or the main electrical designer page where we have the SLD. If you see here the infit IEC option in the project tree also, you can just directly click, so you can navigate into infit configuration, and there you can edit these parameters. Or the second option, just go to the electrical designer, and from this SLD icon here, if you click, you can just see here, from this infit IEC configuration, you can you have the access to edit these input parameters. So from the electrical load configuration, we cannot do anything. Next one is the basic configuration. Here, this is most important and little bit lengthy, so we will go one by one. The first filter is type of load. Whatever the loads are available in the electrical designer, we can change from here. So if you see, we have this 5 loads, and so today we are concentrating on the motor only, so we'll keep it as a motor. Second one is utilization category. So utilization category are defined by the IEC standards and indicate the type of electrical load and duty cycle of the loads to selection of the contactors and relay. This is a read only. It will change if we change the load type. So since motor load is there, our utilization category set AC3 slash AC53A. Then phase connection, the next filter is, and here it's having a 3 option only. So 3 phase motor only, you can configure for a moment in this electrical load configurator if you have the motor load. Then the fourth one is efficiency class of the motor. The efficiency of the electrical motor is a performance parameter, right, that indicates the maximum output of the motor with respect to the input. Here we have 3 options. You can set it as per your motor specification. So if you see here, IE1 slash IE2, IE3 and IE4, these 3 options are there in the efficiency class of motor. Then next parameter is the number of motor poles. In the number of motor poles is directly related to your motor's running speed, right? So here we have 8 options, and here also you can just set anything as per your specification or as per your requirement. So for a demo purpose, I will keep a 4. Then mechanical power, this is a most important filter. Without that, our warning will not go away, right? So here if you see mechanical power in kilowatt, uh, and you set it all, warning will resolve. If once you set it, all the warnings will resolve. So in this list, we have 31 options, so you have to select any one. From the demo, I will select this 31 option. From that 31 options, I will select 5.5 kilowatt, because I saw in industry maximum motors are within a 5.5 kilowatt. Then if you see here, the rated current automatically got calculated by using the root 3 VI cos formula. And now let's talk about a very important detail regarding the rated current. So based on the standard 5.5 kilowatt motor rating, the software automatically calculate a baseline current of 13 ampere. However, you will notice that the system actually allows you to adjust and set this value all the way up to the 31.75. For example, if I try to type here, let's see 35, and so it will auto set on the 31.75. It means that uh, why does it let go that high? Like, it's because the software considered a buffer factor or service factor, the built in margin accounts for real world variables like heavy startup torque, fluctuating mechanical loads, or specific manufacturer tolerance. So while 13 ampere is your standard baseline for 5.5 kilowatt, you have the engineering flexibility to adjust it upward based on your specific applications buffer requirements. So you can set a rated current with buffer factor. So currently I will just make sure that whatever the electrical designer is calculating, I will keep the same, that is a 13 ampere is my rated current. Next parameter is the service factor. So this the service factor represents the motor safety margin for the overload capacity, right? So we have six options here, and if we set our service factor on 1.15, what it means? So it can handle a 15% overload above its rated power, right? So if you have the 5.5 kilowatt and service factor you set it 1.15, then by multiplying 5.5 into 1.15, we'll get 6.325 kilowatt power. So it means that it handles some safety things, safety factor. So motor can safely handle up to 6.32 kilowatt of power under the peak load condition. So this is our service factor. Accordingly, your project requirement, just set it. Then starting current factor is 8.5 watt default set. The starting current factor is the multiplier for your motor's initial inrush current. This helps the software currently size the circuit protection, so it doesn't trip the moment you turn the motor on. Electrical designer has the range between 5 to 15. Default is 8.5. So here starting current factor you can set between the minimum 5. If you try to set it 4, it will by default set a 5, and if you try to set it above 15, let's see 16, then it will be the 15. So the default service factor by electrical designer is 8.5, so let's keep it as the same. Then startup time. So it is the duration in seconds for the motor to accelerate from 0 to full operational speed under the load, right? So in short, the startup time is how many seconds it takes for your motor to reach full operational speed. This is a crucial for configuring the thermal curve of your protection device, right? So it will auto calculate as per your motor power. So we have 3 seconds auto calculate value. If you want to set specific value as per your requirement, then electrical designer has a range between 0.1 seconds to the 40 seconds. So if you see here, startup time calculated automatically, uh, that is a free, but you have this flexibility to change it from 0.1 to 40 seconds. So whatever as per your requirement, again you just set this value. Then overload class, if you see here, if you expand this overload class, you'll get some 5 options, 5 classes. So first of all, overload class is, we also call it a trip class. This detect how quickly the protective device will shut down the system during the overload event to prevent the burning out the motor, right? So electrical designer has the range between class 5 to 40. But these options are dependent on the startup time. If you set startup time 10, then class 5 will not be available. For example, if uh, if I'll set the startup time 10, and if you see now, class 5 will be not there. So it depends on the startup time. So our startup time was previously 3, so that's why all the classes will be available. So it depends on the startup time. The last two filters under these basic configurations are manufacturer and the article number. So these are not mandatory, but see here, manufacturer by default is Siemens, but if you have the other manufacturer motor, just you can select the other, and you can give the name, for example, any manufacturer if you have the motor. So for moment I will just keep the Siemens, and this is not mandatory actually, but let's see, for example, FTD153 something we'll type, and these all things are only for the documentation purpose. Once you type it here, you can see here in the SLT also it will reflect. So it's for the documentation purpose. Then let's see. Now second parameter group is a starting and operating parameter. If you see, just I will collapse this, and I will just open the starting and operating parameters group now. So the first one is motor operating mode. So here you have two options: continuous operation and the periodic intermediate operations. So I choose continuous operation if your motor is going to run constantly for the long period, like a fan or pump, and choose periodic intermediate operation if your motor runs in cycles of starting or stopping, like that. So for example, crane or elevators. Okay, so selecting the correct mode ensures the software accurately calculate the thermal behavior of your system according to your application. Select the motor operating mode. So here for moments the continuous operation will keep, then the actual motor current in the application, it is a 13. So this is a real world operational current your motor will draw under its specific working load rather than the just its maximum nameplate rating, right? So this will auto calculate. Then maximum thermal load current, this parameter, this is the absolute thermal current limit the system can withstand safely before damage occurs to the uh, to the insulation or the components. So now here if you set periodic, then you will get three extra parameters. If you see here, once you select the periodic intermediate operation as a motor operating mode, you'll get the three extra filters. One is the switching cycle per hour, then motor on time per cycle, and effective load current, right? So what it means, so first one is the switching cycle per hour. So this is the frequency of how many times the motor starts and stops within a 1 hour window. Every time the motor starts, it experience a high inrush current, right? So that generates significant heat. The software needs this number to calculate thermal stress accurately. So electrical designer has the range between 1 to 10,000. Default value will be 1, but you can set it between the 1 to 10,000. So set it as per your application, right? So if you see here, 1 is a minimum, and if I can type 10,000, it will accept this value, right? So for a moment I will just keep 1. And then second parameter is the motor on time per cycle. So second is the motor on time per cycle, means this is entered as a percentage. It represents the ratio of the running time versus resting time during the single operating cycle. So for instance, setting this to 20% means what? So it means that the motor rest for the remaining 80% of the cycle to cool down. Okay, so uh, so so 80%, 20% will be motor running timing, and 80% will be the rest time which will use to cool down the motor. That is the that is the what motor on time per cycle in the percentage. Then the effective load current, you don't need to type anything here. This is calculated automatically by the software. It takes your actual application current, your hourly starts, and your on time percentage to output the true thermal equivalent current. This helps determine if the motor will overheat over a time. Okay, this is the maximum thermal load current. Now third parameter group is the advanced configuration. I will collapse starting and operating parameters, and I will open the advanced configuration. Here we have the three filters. Location of the load. So here you'll get the two options: outside cabinet, inside cabinet. So by default it always outside cabinet, but you can set it as per your application. Then part of the resulting current calculation. Here electrical designer has given two options: yes and no. If you set yes, then this load current will consider to select main line protection device. So if you see here, we have the submission symbol. So this load feeder will use to this load feeder current will use to calculate the main line protector device. So if you set it a no, then the summation symbol will be gone. So this motor's current will not consider to calculate or select the main switch. So that is this one. In upcoming videos, I will explain it more. Then maximum allowed voltage drop. So finally, the maximum allowed voltage drop means what? It is the percentage of it is the percentage of line voltage loss you are willing to tolerate over the cable run to ensure the motor operates efficiently, right? So these all the parameters from the electrical load we have set it, and if you see now we don't have any warning. It means that we successfully configured everything. And that brings us to the end of the part 4. Now we we fully understand how to configure both the infeed section and the electrical motor load parameter using the Siemens Electrical Designer. In our next video we are going to take the next crucial step. We'll select the correct protection device for this specific load and calculate the cable sizes. Uh, if you found this video helpful, please hit that like button, subscribe to TechFlow Media so you don't miss part 5, and I will see you in the next tutorial. Thank you.